Hello and welcome to this new video tutorial. This time I would like to show you the t-test for pair samples. This solver is very useful in terms of solving this specific type of t-test that comes with pair samples. What you need to know in order to use the software? Well, you need two samples and they need to be pair samples, meaning one value on one sample is paired directly with a value in the other sample, and you need to have the significance level. All right, here I have an example that I'd like to show you so that we apply this solver concretely to a specific example. So let me pop it up here. So the problem is this. Let's see what it says. It says the management of discount furniture, a change of discount furniture stores in the Northeast, design an incentive plan for salespeople. To evaluate this innovative plan, 12 salespeople were selected at random, and their weekly incomes before and after the plan were recorded. So let's take a look here. So this is obviously paired data because you have one salesperson, you have the before and after for that specific salesperson. For another salesperson, you have the before and the after. So it's obviously paired data, right? And so when you have this paired data, you notice obviously they have to have the same set, the same size. In this case, I'm given here this table in Word, and I just simply, what I'll do is just grab the first sample and copy it, then grab the second sample and then copy it, and I need to find a significance level. So if I scan real quick here, notice that it says use the 0.05 significance level. So nothing to say, quick 0.05, we have it. Now we have to determine what type of tail we have for this test, whether it is a two-tailed test or a left tail or right tail test. So usually you start with the mean difference being equal to 0. That's your null hypothesis. You need to know if it's left or right tail test. So how do we know that? What is that they want to know? They want to know if here, was there a significant increase in the typical salesperson weekly income due to the plan? So they want to know if the income increased. So they want to know whether after income, the income after was greater than the income before. So in a way, they want to know that the difference before minus after, they want that to be negative, or they want to know whether or not it is negative, significantly negative. So in this case, when by definition, the way you do the test, when you put sample 1 here, sample 2 here, what it does is sample 1 minus sample 2. And let's recall, this is the before and this is the after. Hence, what we really want to test if whether or not the before is less than the after, or said differently, whether or not there was an increase. So this is the alternative hypothesis. We want to know whether or not the after is greater than the before. And the way I arranged here, or the way they're arranged the data, since I put the before here and the after here, I have to test this. If otherwise, I put the after on this column and the before in this column, it would have to be the other way around. But in this case, based on the way I organized it, has to be like this. And that's it. Ta-ta-ta. So voila, all you have to do is just click the button, solve, and you have your solution. It's depending on the server, the mood of the server, you're gonna get some speed here. Okay, so you can see here you have a very, very detailed account of the procedure, the reject the null alternative hypotheses, rejection region, critical values, test statistic, all the formula, all the calculations, decision about the null hypothesis, conclusion, confidence interval, and the graphical representation. If you made any mistake here, you need to change any values. Hey, it's not 505, it's 506. Well, just do so, click solve again, and then everything gets updated automatically. Or say you just want to start over because you're not sure, you just click start over and you're good to go. All right, so that's all for now. See you in the next one.